Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Ladies and gentlemen, welcome to this webinar. We will begin shortly. Good morning, good afternoon, and good evening, ladies and gentlemen. Welcome to this live event broadcasted from the Netherlands. We have participants from around the globe in a variety of time zones, so enjoy your morning coffee, afternoon tea, or your evening snack while we get this started. Today, you will learn more about data-driven logistics. What does it mean? Which developments do we see in this area? What are practical examples? And how does the future look like? During this session, these questions and many more will be addressed by 3 speakers, each with a different approach to the topic. Remco Buurman, CEO of the Holland International Distribution Council, will introduce today's program and the speakers and will moderate today's event. Remco, the floor is yours.
Yes, thank you very much, Jelle. Good morning, good afternoon, and good evening, everyone. Another 2 weeks, and then this very strange and special year will come to an end. It is a year with a corona pandemic, which really has changed the business and also our business. It was no longer possible to travel. It was no longer possible to organize events. It was no longer possible to have physical one-to-one meetings. So we had to change our business model. We organized more than 25 webinars this year. And in general, they were very well attended. 50 people, with some exceptions, for instance, in China, where we had 1,700 participants. Today, again, we expect more than 50 attendees. Many of these webinars had as a subject the impact of the pandemic and also such another challenge like the Brexit. And we had less time available to focus on one of our strategic priorities, which is innovation and sustainability. Well, today we have time for one of those topics. Today's topic is data-driven logistics, and we're very pleased to have three excellent speakers today. We have Theodor Thorn of Ortec. He will give you a brief introduction about what data-driven logistics is and in which areas it can be applied. Our next speaker is Mr. Pinak Deshmane. He's Director Analytics at 3SC Analytics, an Indian company with an European office here in Amsterdam. He will also elaborate on the applications for data-driven logistics, and he will also explore a business case together with you. And finally, we have Pepijn Kip. He is researcher at BIT. That's a research and prototyping company, and he will tell what the logistics industry will look like in 20 years and how we will get there. So now I would like to hand over to our first speaker, which is Theodor Thorn. He's the industry lead transportation and logistics at Ortec. Theodor, the floor is yours. Please go ahead.
Thank you, Remco. I'll start share my screen. Do you have the right view on the data-driven logistics topic?
Yes.
Okay. Thank you, Remco, again. Good afternoon. As introduced, my name is Theodor Thorn. I work for Ortec for more than 20 years, being responsible as a business unit manager and as industry lead for transportation and logistics, an important industry. Ortec, in short, is a Dutch company founded in 1981 already, and maybe nice to mention that in the name where there is OR Tech, which comes from Operation Research, also known as Applied Mathematics, and nowadays it's more often called artificial intelligence, machine learning type things. So that's really in the foundation of the company. In this field of expertise, we grew to a recommended global player with around 1,000 colleagues in different continents. As an introduction for this webinar, I would like to give you some context to the subject of data-driven logistics, continuous improvement with advanced analytics. And here it's a slide. We are living in an uncertain world. Well, that's not new. That's been out there for some years. This VUCA world with discomfort, but with the corona virus around, it's even more than it was before. I will not elaborate too much here, as time does not allow. You can read articles and blogs almost everywhere like this one from the end of my colleague, Mr. Gademan, who wrote an article at really in April already about resilient supply chain and let's say the how-tos. As an example, after reading so many reports and checking the news on a regular basis, I've created a single slide for me to try to summarize the overarching trends in a single slide, I said, applicable for logistics and logistics service providers. Reports like Gartner show, let's say, the statement which is in the middle, increased role of technology and the digitalization, and which is even more accelerated in this COVID times. On the left, there is regionalization in contrast to globalization, with trade tensions and so on and so forth. To the top, I noticed quite some information and trends moving on last mile logistics due to this e-commerce, but not necessarily only to the e-commerce. Smaller and more frequent deliveries to a parcel level. This includes you need to have sorting center more close to customers to have shorter distances. But in these regions, then we often notice a shortfall of workers. Then discussion starts about nearshoring or automation and mechanization in warehouses, and also this autonomous driving within the warehouses, but also on the long haul on the long haul for connecting the DCs back and forth. At the top, I put in green last mile logistics. Green as let's say complex and strict legislation in city centers and so needs to be solved with electrification, but also what we notice is an interest to reduce transporting air, which is quite a new topic out there. And at the bottom, I state here there is a focus on cost and efficiency as a logistics service provider. It has always been, and it's maybe even more. That's this cost price plus this marginal business needs to be taken seriously. And it's, let's say, put here, it's achieving operational excellence. You need to digitize and connect all the systems out there, and also to improve continuously. You need data available from these systems. For example, on the right, you can gain insight for studies in network optimization, segmentation, and so on and so forth. To the operational level, the everyday use of decision support and introducing learning cycles to gradually improve operations. Well, these they all require data to achieve this goal, operation excellence. And more than once here, data-driven decisions is mentioned nowadays. We could discuss, of course, about the definition or a definition of data-driven decisions, data-driven logistics. We tend to apply data-driven for advanced analytics, and let's dive in the how-to of it. Data-driven logistics, how-to. With all this news on the digitization, mechanization trends, and also hyped terminology like it's in the sheet here, it all can be overwhelming. And rather quick, you might feel being a bit behind as organization, or have this restlessness to translate it into where can I buy these nice things, which sounds so great. Well, can I say, hold your horses, please. Don't start without a plan. The how-to in our opinion, in my opinion at least, start with a why first. What's your position as a company, as the organization-wise, and the capability of change in your organization? And also, please, it's also not so much about the techie things first, like building a data lake, or I need this and that machine learning algorithm. It starts with the why. Why every company should become data-driven? Well, it's to improve and to better understand and to find opportunities. Look for valuable cases. So we discussed in the slide before, we discussed achieving operational excellence. In step 2 of this how to become data-driven, it's about to check what your maturity level is in terms of data or dealing with digitization, or on the let's say artificial intelligence. What is your capability as an organization in this? We learned to start with first steps before you start with advanced analytics. And a second thing is to not focus too much on the tooling, but to look for a partner capable to help you build your skills as in your organization, or offering this data analytics, data science, data engineering consultants. And thirdly, it's quite important to build a roadmap, which is helpful to start with an effort impact type matrix. Here you can see typical examples of valuable data analytics, and clearly you can see a link with the maturity level in the slide before. There is another level you can map to business domains. So logistics is, let's say, it's warehousing. It can be about the workers, the drivers and the workers in the warehouses, and also about transportation. So if I map it to this business domains, it's about, again, it's for you again to check for the highest priorities to start with. And maybe not surprisingly, with all these years in the business, we feel quite confident serving you there. Moving to examples, we see examples applied in all around the globe, and I'd like to highlight a couple to quickly address them and show the relevance and the applicability of these examples. And of course, I'll leave other examples also to the next speaker. If I go over them one by one, these 5 examples rather quickly. Supply chain visibility is a good starting point to turn your data into valuable insights. And here it's close to this BI tooling still. But a perfect starting point to create a continuous improvement environment in your organization. And in my opinion, this gradual change is so important, is a so important success factor. And next, let's start on the right hand side. Don't know why to start with on the right hand side, by the way. There is a driver incentive program, which is quite common applied in US and ANZ. The case here is to gain insight and to turn it into a kind of game for drivers at the same time. The business case is if employees perform, the company performs. And as a side effect, we measure also less churn and less sickness. So which is quite nice to recognize these bonuses. To the left-hand side, really trending is cost to serve, And cost to serve is really not an easy task to perform. Well, it's so important for your company. The method we apply is on the slide. So what we do, let's say there is a machine learning algorithm to identify the cost impact characteristics, and after there is an allocation algorithm to allocate the cost to individual deliveries, in this case here. So this for multi-drop transportation, we have built an application even, because it's so common at the moment and so trending, so to say. And a reference customer in the US is very pleased with the results, saving up to $1 million or $1 million and above in the first year only. Well, that makes me happy to share with you. Moving to another trending topic is forecasting. At first on the left hand side, so you can read it with me. A better engine, a better model results in a better forecast accuracy. What we see most often still is applications like an Excel sheet with a moving average. And then secondly, if there is a model, if it's automated, it's more easy and of course more often being used in this forecasting. And as a third step, it is to translate it into business requirements. Like you can apply a better forecast or your forecast into order management or in capacity of resources needed. So fleet sizing can be shifts in the shift generation in the warehouses. And this forecast model, of course, is improved by a learning loop, and it's quite common nowadays to make use of external data sources. There are so many external data sources, and mind you, it's not necessarily to add these to the forecast, but some can be very relevant being part of your forecasting. As a last example, I believe everyone knows the example receiving a large box being delivered at your door, but filled with air. Well, this stands for the old process. There is quite often a manual selection in somewhere in the process to look for the carton, then pack the items and ship it to the delivery address. Well, there is a new process. It's possible to calculate very quickly to come up with the suggestion as a black box for the machine or for the worker to come up with the right carton and show and if necessary show how the carton should be filled. Well, this results this case study shows that it results in a very healthy business case. To save 40 cents per carton is not nothing, I must say, and at the same time it is as it is labeled ship less air, it is relevant in the sustainability agenda as well. Okay, as a bigger picture, this business cases presented highlights that it's most often two birds in one stone, so to say. The example above are relevant applications to be able to start quickly, and to conclude here in this how-to, it's the how-to continuous improve. Start with a why, a roadmap, and looking for the right partner. To check your maturity, kind of have a good look in the mirror. Then just start with valuable applications and don't focus too much on the tooling and fancy techniques. It's about what is needed and where it's best to start with. So data-driven logistics is, in our opinion, to make your business more efficient, effective, predictable, and sustainable. Well, thank you for listening. That's my part. Maybe I might recommend here the Ortec Insights, where we share quite some articles, and I have highlighted one in this orange box, like translating data into better decision making. There are quite some articles, but next to Ortec there are so many articles available on this. Back to you, Remco.
Thank you very much, Theodore, for this overview of applications of data-driven logistics. For all the viewers, I would like to tell you that all the presentations will become available after this webinar, and it's also possible to ask some questions. If you move your cursor, then a box or a bar will emerge in the bottom of your screen, and there you will find a box with a question mark. That's the Q&A box. So if you have any questions, please write them down for us. We will try to answer some of these questions at the end of the webinar. If that's not possible, we will publish the answers on our website afterwards as well. So now we will move on to our next speaker, which is Pinak Deshmane from India. He will tell something about, of course, data-driven logistics again, and also he has a very interesting use case which he will explain. And I like the title of his presentation, which is Some Musings. So Pinak, please start with your musings.
Sure. Hope I'm audible and my screen is visible to all. Just a quick check on the mic.
Yeah, everything is working.
Okay, great. Hello, everyone. Thanks for your time to attend this webinar. I am Pinak Deshmane. I lead the supply chain analytics function at 3AC Solution. In line with today's theme, I'm going to share a few personal thoughts on data-driven logistics, and share some of our organization's experience in this domain. So I intend to touch upon a couple of points. So highlight some of the trends and challenges that we see, especially in the supply chain logistics domain. And I thought it would be a good opportunity for us to kind of bring it to life through a use case study, how we are utilizing some of these technologies, what are some of the challenges that are faced by our clients, and how we are kind of helping them deliver value to their clients. And then finally, just talk about who we are and what do we do. Yeah. So moving on. So if we talk about this theme, data-driven logistics, I think the key point here is data-driven. Now, if we were to look at the past, maybe 5 years, 6 years ago, getting data was a big challenge. So there were different islands of systems, and getting data was a big challenge. But with the advances in technology, computing power of chips, memory, low-cost sensors, data capturing has relatively become much easier. So right now, the challenge is not so much of data capturing, but how do you make sense of that data? So how do you translate that data into business insights to create value for the customers or society at large? So really, these are some of the trends, and this, by no stretch of imagination, this is the complete list of trends. There are kind of few more, but I just highlighted these as trends which we see here and now. So a lot of companies have started implementing it, or kind of moving from pivot to large scale implementation. So the first one being IoT. It's being used everywhere, whether it is in manufacturing, trying to get a sense of what's real-time manufacturing happening in terms of predictive maintenance and so on and so forth. In logistics, track and trace, preventive maintenance, predictive analytics. Also in supply chain, you try to get the capture demand data from point of sale, secondary sales, demographics, and so on and so forth. So IoT is here and now. Companies have started implementing it. Concurrent planning. So how do you utilize all that information to do real-time demand planning, supply planning, capacity planning, logistics planning? So it's more of how do you get that data and do real-time planning. So gone are the days when you run MRP, you do a batch processing, you run a nightly job, you come onto the work and then look at what the requisitions are. Now everything is concurrent planning. It has to be real-time. Obviously, the next is predictive prescriptive analytics, and Theodore touched upon this. So with that data, how do you use predictive and prescriptive analytics through AI, ML, machine learning models? Whether it could be in terms of demand forecasting, or it could be in terms of route optimization, vehicle optimization, inventory modeling, so on and so forth. The next is warehouse robotics. This is a bit interesting one because automation in warehouse has been there. It's been around for so many years. But with the advent of e-commerce and big players like Amazon, it's really kind of moving the dial. So if we were to compare against, say, manufacturing. Now, manufacturing by and large is already automated. So you've got SCADA systems, you've got PLCs, you've got a lot of sensors, and a lot of it's almost like a touchless operation. Now, if we were to apply the same logic to warehouse, I mean, in few years, the entire warehouse would be autonomous warehouse. So not just pick and pack, but things like cycle counting or loading, auto gate system. All those would just get digitized and automated. So that's more on autonomous warehouse. Blockchain, it's not gotten the commercial success outside of the banking and financial industry, but that this is something that is going to be the next kid on the block, so to say. So this is definitely a lot of companies are getting into blockchain. With regards to logistics and supply chain, there are large number of cases largely in the smart contracts. So when you're dealing with a lot of contracts, a lot of players, a lot of logistics players and things like that, blockchain helps quite well. And the other is on the export import. So where you got large number of stakeholders, whether it is the customs clearance, export import documentation, the CHAs, the freight forwarders, and so on and so forth. So within the supply chain logistics, blockchain is really finding its feet in the entire smart contracts and the entire export import. Autonomous vehicles, and our next speaker, Papine, will talk about what's going to happen in the next 15-20 years. But I think looking at the autonomous vehicle, there are a lot of companies have already started doing the pilots. So be it Waymo or General Motors or Ford, Tesla, Baidu, they've all started testing their autonomous vehicles and piloting it across cities. But in terms of freight forwarding, Volvo has already started and piloting driverless trucks in Europe. And I think maybe I don't recollect, but they do have plans to commercialize it as early as in the next 2-3 years. So obviously that's Theodore talk about worker unavailability and issues. So talking about some countries where we've got challenges in truck drivers and stuff like that, this is really going to be a big change in the entire supply chain and logistics field. And lastly, sustainability. So obviously, with all this, how do you make your organization purpose driven? So how do you ensure that you move towards a sustainable logistics or sustainable supply chain? So those are really some of the trends that we are seeing with a lot of the clients. Obviously, there are huge challenges. The big challenge is last mile delivery. And again, Theodore, our first speaker, touched upon this. So this is going to be a big challenge, given the urbanization, finding out the warehousing spaces, finding the workers, making sure the customer gets the delivery within not just 4 hours, maybe 30 minutes, 15 minutes, and so on and so forth. So last mile delivery is going to be a big challenge. End-to-end real-time visibility. So although we've got all the data capturing techniques, the end-to-end real-time visibility is still a challenge. There are different islands of information. How do you kind of get all that information, stitch all the pieces together and provide those insights. So that's still a challenge. Interoperability. There are different systems, although they talk to each other, we can build those APIs and interfaces, but still there are challenges in some pockets. So interoperability still is a challenge. And finally, data security. This is with GDPR or cybersecurity and stuff like that. So there are challenges, and how do we ensure the data is secured, the client information is secured, and it's not passed out onto competition or any nuances, right? So those are some of the challenges that we see in the logistics domain. Now, moving on to the case study. So whatever we spoke about, how do we bring it to life? So I think this is one of the very interesting case, and what it makes it interesting is on the client. It's a leading provider of temperature control containers to pharma industry. Especially this becomes very important in the current scenario. So this client of ours makes temperature controlled containers. It's a European client, and their customers are all the big multinational pharma companies, whether it is GSK, Roche, AstraZeneca, Takeda, and so on and so forth. So these containers ship vaccines, APIs, and other stuff which require temperature control monitoring. Our client works with 25 of these pharma companies, 70 forwarders, 20 airlines. The entire logistics happens on 120 lanes, and there are 10 service centers apart from the manufacturing unit. So it's a huge complex tasks that they manage. Now, in terms of challenges, obviously, when you've got so many people, stakeholders in the entire supply chain, the visibility becomes a challenge. How do we ensure that there is real-time visibility into the containers, into their products, and stuff like that? Their entire processes were manual, leading to entire high order cycle time. There's a lot of supply-demand mismatches leading to high inventory. Finally, that reduced the asset utilization, and there was high logistics cost. So in terms of solutions, we deployed a 24/7 control tower, leveraging IoT, descriptive and predictive analytics, and inventory optimizer models. Now, this all looks fine, but I want to spend the next couple of slides which will give an idea of what their operations were and how we went about deploying it. So this is just a quick summary, a very high level summary of their operations, so that you get a flavor of the different complexities involved in this supply chain, the kind of different data that is getting generated at each stage, and how we are capturing that data, generating those insights, and then creating value for our customers, and then customers' customers, right? So the entire process starts with the pharma company placing an order via email to this client of ours, who is the container manufacturer. Once they get that email, our client then punches the orders. The data is captured in an Excel. They do a manual check of container availability across all their centers across the world. They look at what lane, what size, what is the type of container they need, what is the kind of medicines they're carrying. Then if the service centers do not have inventory, they check back on their manufacturing sites. So they look at what is available to promise, capable to promise, and then they promise the containers to the pharma company. All this is Excel-based forecasting. So when I say forecasting, they forecast what kind of containers would be required at which lane. And so it's all Excel-based. They do manual inventory sizing. So as you see, there's a lot of manual processes that are happening. And again, it's non-productive. Once they allocate the containers to the pharma company, the step 3, which is the leg 1 of the entire supply chain, starts. So they ship the entire empty container. It could be either by airline or it could be by truck, depending on where the service center and manufacturing location is. And it goes to the loading point of the pharma company. So if it is, say, Roche Pharma would be placing an order, and then this empty container would go to a Roche loading center. So again, once the empty container travels this stretch, there's a lot of data points that are generated. Obviously, we want to understand where the truck is, what time it will, what's the ETD, ETA, what time it's been reached at the loading point. So that's all the data that's captured currently manually at the end of the day, and they again punch it in the Excel, and then they create reports. So that's leg 1. Moving on to leg 2, once the medicines are loaded onto the truck, the leg 2 starts. So again, the truck goes to the origin port, which is the airport. It does the customs clearance. So again, once the medicines are loaded onto the freight forwarder, we definitely want to track what's the condition of those medicines, what's the temperature, humidity, and so on and so forth. So again, a ton of data is generated on this stretch. And again, it's not real time. So at the end of the day, the freight forwarder would send an email to our client. The client would punch that in Excel, and then they will ship it back to the pharma company or their client. So again, it's a long lead time. Once this stuff gets cleared on the origin port, it gets customs cleared and it gets loaded onto the airline. Obviously, again, there's a ton of paperwork that is generated. Everything is, again, manual customs clearance, pre and post shipment documentation, coordination with agents, CHA, airlines, and all this information is either in an Excel sheet or emails. You again need to consolidate it and then send it to all different stakeholders. Finally, it comes to the destination port where it's again custom cleared, and then the leg 6 starts, wherein it again is handed over to a different freight forwarder. It goes to the unloading point of this pharma company. So if it is taking the same example of Roche Pharma, so this medicines would get delivered at Roche Pharma unloading point. Then this is at the customer end. And then finally is the last leg, wherein the empty container goes back to our client service center. So again, if you look at this entire story, there's a lot of manual processes, a lot of data that is generated. You need to have a real-time visibility. There's a lot of manual Excel-based forecasting that is done. There's a lot of inventory mismatches. So if we were to summarize the key challenges, obviously, in terms of the productivity, there's a huge drain. So almost about 1,500 hours per month is spent on non-value-add tasks, whether it is order management, looking at inventory in different service centers, in manufacturing, in promising to the orders, in tracking the entire shipment through this entire chain. So about 10 people are deployed full-time to manage this activity. As a result, obviously you have got high people cost, but there's also high inventory cost and logistics cost, because if the inventory is not there at the service center, you tend to manufacture more inventory. So the supply demand mismatches, and at the end of the day, you end up having huge inventory. And these containers are pretty costly. So you really don't want to have your inventory blocked in, or rather working capital blocked in the inventory. And there's high logistics cost because everything is air shipped. Even each and every leg is air shipped. Large part of it is air shipped. So it is high logistics cost. And finally, sustainability, because it is air shipped, it leads to a high carbon footprint. So given these challenges, how did we go about it? So obviously, we used few of the technologies to implement and drive value. So we implemented a 24/7 control tower service. We started with level 1. So again, as Theodore mentioned, start with the simple things first. So we started with getting data collated automatically. So we put in the IoT. We automated the order management, we automated the pre and post shipment documentation. So we looked at all the areas where there were manual processes. We first automated that. So that was a relatively simple task to start with. Level 2 was implementing the entire descriptive and diagnostic analysis. So how do we do performance management? So if we want to see where are my containers across the world, whether it is in the service center, whether it is in manufacturing, whether it is an empty container, whether it is in transit, how long will it take to get back to the service center? So it's all part of descriptive analytics and performance management. Root cause analysis and risk management. So if a container has gotten delayed, why did it get delayed? Whether it was because of customs documentation or a freight forwarder issue, or inventory issue and things like that. And finally, risk. So given that there is a delay, how do I overcome that risk? And what are the different actions that could be taken to ensure the containers get back on track to our client? So once the descriptive and diagnostic analytics was done, we moved to the level 3, which was predictive. So given that all the data that we have, how do we start predicting what would be the container requirement at each of the service centers? So it's one thing to have several containers floating around across the globe, but how do we ensure the right container, the right SKU of the right capacity is available at the right service center? So looking at the past data, looking at the entire inputs that we get from the team, we created predictive AI ML models to kind of highlight what inventory we need to be keeping at which service center. And then In terms of the predictive analytics, we also started looking at when would the container reach a customer point and what are the different milestones. So we started predicting it and then started optimizing the entire inventory. Finally, level 4 was prescriptive analytics. So how do we manage our inventory? What are the min-max levels of inventory at manufacturing site, or it could be at service center. It could be also in terms of equipment and transport optimization. So if you recollect, I mentioned that most of the shipments were air shipments. So when we looked at this data, we realized what is the lead time it takes for us to move a container from one place to the other on given a certain day. So looking at the lead time, we kind of modeled whether it really makes sense to ship 100% by air, or could there be a business case to move some by sea shipment and some by road trucks. And almost we realized that there was a business case where we could move about 20% of our shipments to road and still meet the delivery lead times as asked by the client's customers, right? So this was all about how do we optimize your transport? How do you ensure that you've got the right truck capacity? And how do we move to a multimodal mix from air to land and sea? So these were the 4 different levels that we started from level 1 and graduated to level 4. In terms of the key benefits delivered to the client, we had a 10% inventory saving in terms of the container. So with less number of containers, we were able to deliver the same service levels to our clients' customers. The container turnaround time increased because now we had visibility of the entire containers in the entire chain, and we were able to better predict what would be the container requirement. Load consolidation, we could do load consolidation across different customers. And finally, because we shifted from our air shipment to sea and land, we were able to cut down 15% on carbon footprint. So that's really does well to ensure that we are providing a purpose-driven, so to say, a mission to reduce the entire carbon footprint. So that was about in a nutshell. I'm keeping an eye on the time. So if there's any interest, we can definitely talk more about our use case. About us, so we are an analytics company based in India. We've got a couple of subsidiaries in Amsterdam, and one more will come up in Germany in next month. We provide cloud-based services as well as analytics as service, whether in predictive, prescriptive, descriptive, and we also provide global control tower services for our clients across the world. So that's about our organization. I think the use case that we shared was very interesting, and I'm sure that all of us on this call at some point of time in the next year would get vaccinated for Corona. And we are happy that we would have played some part in handling the entire logistics and optimizing the entire thing and getting the vaccines to your country, to your district. So really happy to be part of this entire part of this client and part of driving solutions to make a world a better place. So that's all for me. Back to you, Ramco.
Yes, thank you very much, Pinak, for your clear presentation. Once again, if you have any questions, please use the question mark on the bar below in your screen. We immediately continue with our next speaker because we have limited time left. So we will try to answer 2 or 3 of the questions afterwards. But for now, we immediately move on to our next speaker, which is Pepijn Kip. Pepijn, please go ahead.
Thank you, Remco. I will talk as fast as I possibly can. Let me share my screen. Are you able to see my screen?
Yes, we are able to see your screen. Perfect. Thank you.
Great. Well, hi there. My name is Pepijn. I'm a design researcher at BIT. I will tell shortly what BIT does. And afterwards, of course, I will talk about the future of data-driven logistics, because I think you all are there for that. BIT is a research and development prototyping studio. And we focus specifically on emerging tech we see in the world. And by doing so, we try to help our customers innovate successfully. And why do we do that? Because we believe the biggest management challenge in the 21st century is to innovate effectively. And well, we do not believe that out of thin air, so to say. If you look at Martek's law, for instance, you can see that technological change happens much faster than organizations can change themselves. And you see actually that the gap is widening. So it's very important to bridge that gap, and I think keeping up with technological change can help organizations in that sense. And that is why we say to our customers, you should skate where the puck is going. And this is a phrase. Well, you can guess it comes from ice hockey. It's a quote from Wayne Gretzky, one of the best ice hockey players that Canada has known. And his father used to tell him, Wayne, if you skate after the puck, you have to skate very fast to be the first at the puck. If you look at where the puck is going and then skate there, you don't have to skate that fast to be first. And this metaphor is basically what we try to do for our customers and what we do at BIT. And we do that by informing, activating, and optimizing our customers. Informing, if you think about the ice hockey pitch, is really watching where the puck is going, and we do this by by scouting developments we see at R&D labs, university, and startups all over the world. So not only in the Netherlands, and we try to connect them to the opportunities we see for our clients, by really empathize and well, being obsessed with the world of the customer where they live in. If we find an opportunity, we try to prototype it by the opportunity to see if the spotted opportunity works. So when you think about ice hockey, this would really be skate towards the puck or to where you think the puck is going. And once an idea is validated, we try to optimize. And this is basically trying to incorporate a validated idea into the running organization or operation. And yeah, now you can score when you have the puck. That being said, that is in very brief what BIT does. We inform, we activate, and we optimize. So let's talk now about the future of data-driven logistics. And I realize this is a very broad field. And instead of trying to cover everything, I would like to share one idea I think is worth sharing with you to start off. And that is that in 15 years from now, logistic trucks will drive in convoys operating fully autonomous. And there are already experience being done with this. And I would like to walk you through how I think we will get there with our maturity wave. We designed the maturity wave to really plot technologies we scout and estimate how far we think the technology is from becoming mainstream adopted. And here you see a few examples that I think has very much to do with trucks becoming fully autonomous. And well, when you start at the far right, you see sci-fi. Sci-fi technologies are technologies that are being researched somehow, but there are no concrete use cases yet. There's no business case yet. There are no companies heavily investing in it yet. And when you move to the lab prototypes, there are this is a phase where technologies are typically investigated by R&D labs. And the technology works, but only in a lab setting. And as soon as the feasibility is proven in a lab setting, you see it moving to the first application. And this is where startups start working with the technology, really try to prove the value the technology has. It's still 5 to 10 years from mainstream adoption. And what very important is in this phase, in the first application phase, is that the technology does not outvalue current alternatives yet. And this is blockchain was mentioned by Pinak. This is one of the reasons why blockchain never really made it to potential unlocked, because the current alternatives are in very many contexts better than blockchain. But if the technology gets to the potential unlocked phase, it really gets fast, because from that moment on, everyone dives into it, and it's a matter of time before it becomes mainstream adoption and mainstream adopted. And as soon as it is mainstream adopted, you are late as a company to become a front runner in a certain technology. And after mainstream adoption, we say that technology is invisible. And what we mean by that is that it is so commonly adopted by the world that we do not recognize it anymore as tech or new tech. An example would be the iPhone in your pocket right now. So autonomous trucks in 15 years, I will highlight 3 technologies in a different phase that really will help trucks becoming autonomous. And I will start with vehicle to everything technology, V2X. This is the furthest away from us right now. And when you think about autonomous driving, you think about awareness, circumstantial awareness specifically. And this is basically what vehicle to everything is. Vehicle to everything it goes from the assumption that the vehicle connects to every device that is in its surroundings. And now there might be few. In the future, there will be a lot. The estimate is that in 2025 there will be 40 billion connected devices in the world. So this will basically mean that a vehicle connects to traffic lights, pedestrians wearing a smartwatch or an iPhone, electric bikes, other cars, roadblocks, maybe even pets or dogs in the future. And as you can imagine, this generates massive loads of data, massive amounts of data. This is I found this picture quite funny. This was the most powerful computer in Spain last year, the Mare Nostrum. And this computer was used by SEAT only to process data on how the new design of a car should look like. So you can imagine that if you are going to work with vehicle to everything technology, the amounts of data will be even bigger. And for that reason, cloud computing is no longer an option. You would really move to edge computing. Because of 2 main reasons: the data load. There are too many data otherwise going to the cloud, and even more important, the latency issues. Autonomous driving will only work when you have immediate response from the steering wheel, so to say. You cannot wait a few seconds due to cloud connection. So have your infrastructure when it comes to edge computing in place when you think about this technology. The second is digital twin. A digital twin is actually a copy of the software that setting and is able to run simulations on foreseen and unforeseen situations. And you might think, oh, how is this going to help autonomous driving trucks? Well, I show you why with a quote. Autonomous vehicles would have to be driven 11 billion miles to determine their reliability. With a fleet of 100 autonomous vehicles, test driven 24 hours a day, 365 days a year, this take 518 years. Well, this is basically why you need a digital twin. Nobody wants to wait 500 years. And this is how a digital twin helps accelerating autonomous driving. Two being covered right now, the vehicle to everything and the digital twin, both not really arrived here. Pre-trained AI is. So this is also a wake-up call. Pre-trained AI is a solution that you already can get as a company, and it is an off-the-shelf solution, so to say. And the easy thing about pre-trained AI, they are open source. So there are open source algorithms that only require a bit of training before taking it to use. And they're often trained for very similar situations they put in afterwards. So you only need to do some small adaptations or some training and learning to have the model working effectively. And this is something you can start off already. And another thing I would like to highlight to you about training AI with computer vision is the different approaches you see to it. I think most of you know this this symbol with the text "I'm not a robot," and I think even more of you will recognize this. This is you proving you're not a robot by saying where the traffic lights are. And what you are doing here is you are training Google's AI, the Waymo, the self-driving technology Google is developing. And what is good to know is that Waymo is a bit on the opposite of the spectrum when it comes to self-driving cars. When you compare it to Tesla, Waymo is using supervised learning, while Tesla is using unsupervised learning. And it's in the name already. Supervised learning. In supervised learning, the algorithm is supervised. So the things or the objects that the Waymo would classify are checked by a training set that says, hey, you're wrong or you're right. And this is very useful when you want to use it for classification or regression problems. You need, however, a very, very clean data set as training set. And this is difficult to get or very expensive to get and to maintain. And what Tesla is doing, they use unsupervised learning. And that means that software just gets a lot of data into it as input. And the algorithm itself has to make sense of what is what. And it trains itself. There's no training data. It's not supervised. So that's, that's interesting to look at training AI for self-driving vehicles. This stuff is quite cool. I think three technologies that will really contribute to the fact that in 15 years from now, trucks will drive fully autonomous and operate fully autonomous. What is also cool is when you look a bit further, you see other technologies already emerging that will, I think, really disrupt the logistic sector. And two, I would like to highlight to you, and it's the fact that containers might get senses that outperform the senses of humans, and the fact that trucks will become self-healing. So what do I mean by that? Living containers. For instance, there is research now being done on patches that you patch to products such as a piece of salmon, and it recognizes when the food is spoiled by changing the color. And actually, this specific patches, they recognize E. coli and Salmonella. And imagine when you attach such a pad to your freight, in the future the container might have a skin that actually changes its color when it feels that your freight is being spoiled. The other one is a nose. Airbus and Konica are developing a sniffing sensor, so to say. They have the same specs as the nose of a dog. And in aircrafts, they are now being tested to detect bombs, to detect viruses, to detect drugs. But imagine what this could do for logistics, and imagine what this could do if you would combine it with the technology, for instance, I just will show to you. Another cool thing is the self-healing trucks. Their researchers are better and better in developing metals in specific aluminum that repairs itself. So when you in the future will start building trucks like this that are made of that material, they won't need any reparation anymore, and the lifetime will be extended by 25 times, which is, I think, a very valuable technology for logistics as well. I know, and I think there are many more developments when it comes to data-driven logistics, but these were just a few I wanted to share with you. And 5:02, I would like to give the word back to Remco. Thank you.
Thank you very much, Pepijn, for this interesting presentation. Thank you to all three speakers for your excellent presentations. Indeed, it's already 2 minutes past 5. Still, I would like to ask one more question to all the participants, and maybe you can just give a brief answer to that. And that is related to the ownership of the data. Of course, it's obvious that some of the data are owned by companies. Some of the data are gathered by several institutions. What to do? Because on the other hand, it could be an opportunity to share a lot of this data to fasten the speed of certain developments, like Pepijn just said. So how do you look at the ownership of data? How can we find the right balance between data in the public domain and the business-related data? Theodore, can you start by saying something to that?
Yeah, a quick opinion there. A quick opinion on the ownership of data. I believe that, let's say, we strictly following the rules and legislation as put out on European level and US level. It's so important because the ownership of the data is, let's say, it is in the name of ownership. It is owned by you, and so there is a specific consent for it. Of course, there are valuable cases to be thought after if data is available, but if there is no consent that it's, let's say, that you can benefit or make use of the data, you shouldn't do. That's my opinion, and that's what I like to share here for now.
Okay, thank you. And Pinak, maybe you also, you mentioned the blockchain. Well, blockchain, of course, is dependent also on some privately owned data. Can you give your opinion about it?
Oh, yeah, absolutely. So again, just 2 cents here. So on blockchain, yes, absolutely, data is very critical. But once you get onto a shared platform on the data, I think it's when I talk about the privately secured, it's for all the parties. So all the parties are involved in the blockchain. So it becomes a common data. So it's nothing about sharing someone's information there. So it's all parties are consent to it and they form the private chain. So I don't. Of course, you need to have cybersecurity laws and ensure that the data is well encrypted. But yeah, I think the blockchain technologies, at least the ones that we know, Ethereum and the other stuff, are quite good in terms of handling the blocks. And the implementations that we've done with a couple of clients do show that it's quite doable.
Thank you, Pinak. A final word for you, Pepijn.
Yeah, I think data sharing with the rest of the ecosystem or supply chain is key. If you cannot be the owner of the data directly, get them via sharing, because I think the B2C, so the business to customer is in this case maybe B2B. It's very valuable to get data of the client you're working for, and I think what you see is that a lot of large firms have problems now with getting data of their customers. When you look at, for instance, Levi's selling jeans on Zalando, well, Zalando has the customer the data, and Levi's does not really know what's going on. So taking control of your data, incoming data, is very important, I would say.
Thank you very much. So I think that could be a very nice topic for another webinar, so to say. Once again, I would like to thank all three speakers. I would like to thank all the viewers of today. I think it must have been very interesting for you. If you have any questions, please send us a mail and we will forward this mail to our speakers. Thank you again, and if you don't join us tomorrow during our next Brexit webinar, I would say have a nice holidays and a happy start of the new year, and stay all healthy. Bye-bye.
Bye.
Thank you. Bye-bye.